Alright, this is Chapter 2, Section 7. So in Section 5, we established the measures of center, or where the middle of the data is, with mean, median, mode, and mid-range. Once you know your middle of your data, right, so your middle of your data, the question is how spread out is your data, how dispersed is your data. So dispersion or spread, however you want to either use those either way. So the three calculations we use are range. So the first one, range, is basically from the the biggest to the lowest number, high and low. What is that distance? And then how spread out it is within there is these ones essentially. Excuse me. So range is pretty easy. If my numbers are 3, 5, 6, and 8, and the range would be 8 minus 3, which is 5 essentially. So it's like the driving range of the distance of 5 from here to here essentially. So even if I repeat a number, like the 3 twice, it's not going to change the range. It'll change the other two, the variance and standard deviation. So let's talk about the mean deviation. So to first understand a deviation, you have to know where the center of the data is. So we first need to understand the mean. So the mean, if I add those up, I get 25, and if I divide by 5, I get 25, right? So the center of my data is 5, right? So if I take the mean deviation, which means take the deviation of every single number, so how far is 6 from 5? How far is 3 from 5, right? Well, 6 is 1 more than 5. 3 is below 5 by 2, correct? 8 is above 5 by 3. 5 is at 5, so there's no deviation there whatsoever. It's just right on the money, basically. And then 3 is below 5 by 2, essentially, right? So those are my numbers. Okay, so if I add all of those up and divide by how many there are, so add up 1, negative 2, 3, 0, and negative 2, okay, I'll get an average of 0, essentially, right? Oops, let me get rid of that. There we go. So what's really doing is it's balancing it out essentially for around the center. So you should get 0. So what you do is you do an absolute deviation, which means you do the absolute value of all those values basically. So the absolute value of 1 is 1, the absolute value of negative 2 is 2, the absolute value of 3 is 3, 0 is 0, and then negative 2 is 2. So essentially what you're doing is you're just making them all positive there if they weren't already, right? So I'll put those down there. Let's see if I can paste them in there. Oh, it's not going to let me, is it? Right, so this just becomes 6, 3, and what am I doing? Not 6, what am I doing? Copy this right here. 1, 2, and 3, and 0, and 2. There we go. Okay. Those become the mean deviations. There we go. Okay. So the mean absolute deviation, otherwise known as the MAD, is the mean distance the data is from the mean. Which sounds redundant, but it's not, because it's mean distance, so it's like the average distance it is from the mean, which our mean in this case is a positive 5, right? And so we figured out. Okay. So you just do the same thing we did before, but now we do the absolute value of each one of those, right? So if I add them up and divide by 5, right, I will get 1.6. So the average data value is 1.6 away from 5, essentially. Some are above 5, some are below 5, but the MAD, or the mean absolute deviation, is 1.6. Okay, but typically you don't do MAD, you do standard deviation, which is what's done in statistics. This is just done at a very elementary level, but it gives you a general understanding of what's going on, basically, right? So first we want to do variance, right? So we want to square the values, okay? So they use S for sample, and then use obviously the Greek letters for the population, and there's a -1, which is a population correction factor. And you'll notice there's 2 formulas here, so these are both the same formula, essentially. They're algebraically exactly the same. We're going to typically stick with this formula here because we do spreadsheets, and this is much easier to do with spreadsheets, right? So values either above or below the center of the data, basically, right? And we want to do what is the variance, basically. Okay, so first we need the mean of all of these, right, which we already have. I can copy that from before. Alright, so we already know our, whoops, let me go wrong page there. We already know what this is, right? So the matter at this point is we want these values here, alright? Okay, bring this up. Okay, so, on the wrong screen, format color blue. Okay, let me shrink that down a little bit. Alright, so if we do our little fraction here on the bottom, we're just going to get 5 minus 1 since there's 5 values, right? And the rest of these are going to be 3 minus 5 squared. Okay, because the 3 is the first number in the list and the mean is 5. And then we add the next one, which would be another 3, right? Copy the whole thing. Copy, paste. The next number is a 3. The next number is a 5. Right? And the next number is a 6. And the next number is an 8. Okay, so we need so these are the square of the deviations basically, 3, 3, 5, 6, 8, right? And the mean is 5, which we already calculated in the prior section of these numbers, right? Alright, so if I do a little quick math in my head here, right, that's going to give me 4 on the bottom, right? 3 minus 5 is negative 2 squared is 4, right? So that's going to give me 4 plus 0 plus 1 plus 9, right? Because 8 minus 5 is 3, squared I get 9. Alright, so that's going to give me 18 over 4, which is 4.5, right? So that is my variance. Okay, so we want to do standard deviation, which is SD, or sometimes they'll abbreviate it as like STDev in the software, right? So so basically MAD. So they do the elementary level. Within statistics and high level, we want to do standard deviation, right? Which is the measure of how the data values deviate from the mean, right? And what you'll notice about these formulas is the variance formula and the standard deviation formula are very similar, except now it is essentially just S, right? And it's not, that means you get a square root it correct, because you take S squared, you square root it, you get that correct. Alright, so let's cheat a little bit. We'll copy this, right? And we'll paste it down here. But we know that in fact we don't need all of this, right? So we're going to get rid of all that. So then in fact my S is, let's make that blue, format color blue, is the square root of this, which essentially is the square root of 4.5. Okay? So either one of those, depending on what you're trying to do, is fine, basically. And you can get the decimal value out of that, which is like 2 point something, right? I don't know what that 2 point something is. I don't know, essentially. Okay? So the average value deviates by about a square root of 4.5 or 2 point something, essentially, right? Okay, so obviously your typical data sets are not 5 numbers, they are way more than that, right? So what we want to do here is range, variance, standard deviation for a large data set. So if you go to Canvas, under your lecture notes, you'll find a, let's go to lecture notes here. Oh, wrong class. Statistics, and modules, and lecture notes. Lecture documents. Okay, so there's the chapter 2 data right there, right? Part 1 data, part 2 data, download the data, okay? And then drop it into your OneDrive. So I'm going to drop it in my OneDrive, so it's right there. Right, so just go to your office.com, go to your OneDrive, drop it in there, and we can open it in the browser. Okay, so I'm going to rename this as 2-7. Okay, so this is our variance and standard deviation. So we want to do, we'll go over to your little room here, range, variance, and standard deviation, right? Oops, let's put the equals in front here. Okay, right, so this is max minus min, correct? So we're going to do equals the max. Oop, let's just can't do that because we need to put these in order. So I'm going to click this, and we'll do this in order. So we'll do data and sort it. Okay, so this will be max minus the min. Okay, so we're going to get 11 there. So the variance, we're going to need to do some of the formula stuff. So the problem is, if you look at the formulas here, okay, we need the mean first, don't we? So I'm going to do the mean, okay, and we also need n. Alright, so we're going to do, whoop, that's not what I want. I want to do that. There we go. Alright, so the sum of all those values, and there are 40 of them, so we're going to divide by 40. So that is the sample mean, right? That's the x bar. And you can count them if you need to by doing the count, which we already know there's 40. Okay, so there's 40 values, right? Okay, so this is the individual value, so we want the individual value minus the mean squared, right? So this is the numerator right here, right? Correct? Oh, come on, can I get the little thing work? Right, that's the numerator right here, right? That's what we want. The problem is we need to do it for all of them and add them up, don't we? We need to add them up. Okay, but so if I drag this down, it's not going to work. It's because if you look, it's going down to this random box down here, right? Right, these random boxes down here. We need to do the dollar signs on the E4. So now when I drag this down, right, no matter which one of these I click on, it's using the actual mean, right? Okay, so the variance is the sum of all of those squared deviations, right? Divided by parentheses n minus 1. Okay, so there is our variance, and therefore we need to square root that value, and that'll give us our standard deviation essentially. Okay, so going back to the notes, we fill in the things that we got for the chocolate chip data. Okay. Let's see if I can get this back up here. Here we go. Okay, so we added them up and divided by 40. We got 23.95. That's what we got, right? 23.95. Correct right there. And then we did 19 minus, right, because 19 is the lowest value on the list, right? If you look at the list here, 19 minus the mean squared, right? So we went through then 19 again, and all the way the last value is 30, which is the largest value, right? Then we divided by 39, so we get 6.51, right? 6.51. And essentially all we have to do is square root that to get the standard deviation. Okay, so typically you're going to do this in the spreadsheet. So this is the manual method for doing the calculations, which I want you to do for this section. All right, that's the end of this part.